So today we will be discussing about frequency response analysis. So we have done time domain analysis. Till now we are doing time domain analysis. Means how your system will be responding with respect to time we are discussing. So generally when we are discussing time domain analysis, the input is impulse, step, ramp, parabolic, and somehow it is sinusoidal also. But when we are talking about this impulse, step, ramp, and parabolic input, they are variable of t only. But when we are discussing the sinusoidal input, it will be sine omega t. So it will be depending on omega also, and it will be depending on t also. So if we are doing only the time domain analysis for the sinusoidal input, it will be not giving us the perfect result which we require, because it does not compensate the variation in frequency, that is omega. So because it is not considering the variation of omega, so and most of the signal which are available are sinusoidal in nature, because whenever we are talking about AC signal, it is sinusoidal waveform. And these response of the system may be time response or frequency response. So when we are talking about sinusoidal, we require to find out the time response and also the frequency response of the system. For time response, the input may be impulse, step, ramp, and parabolic. And for frequency response, the input must be sinusoidal. So we have a linear system where RT equal to A sine omega t. Under steady state, the system output is also sinusoidal. Let's consider steady state output as it will be function of sine, so it will be A sine omega t plus phi. The magnitude and phase relationship between the sinusoidal input and the steady state output of the system is known as the frequency response of the system. In linear time invariant system, the frequency response is independent of the magnitude and phase of the input signal. So when we are talking about frequency response, so we are only focusing on the omega of the system. It does not depend on the magnitude, and it does not also depend on the phase angle of the system. So when we are doing frequency domain analysis, so we will be considering a fixed amplitude, we are considering only a fixed amplitude, and determine the response of the system for range of frequencies. So in frequency domain analysis, we will be, for analysis purpose, we are considering only the amplitude as a fixed quantity, and we are varying the frequency of the system, and then we will be finding the response. So the advantage which are associated with frequency domain analysis as compared to time domain analysis is, first, signal generators and instruments are available for various frequencies. So it is very easy. We are able to understand or analyze the system response for various signal generators. And AC equipments have high efficiency. Then third, wherever it is not possible to obtain the form of the transfer function of the system through analytical techniques, the necessary information to compute a transfer function can be done with the help of frequency response test. So for physical system, easy to find transfer function by help of frequency response test. Anyone want to say anything? The design and parameter adjustment of the open loop transfer function of a system for a specified closed loop performance is carried out somewhat more easily in frequency domain as compared to time domain. So next is design is easy as compared to time domain. The effect of noise disturbance and parameter variation are relatively easy. So these are some of the advantages when we are comparing it with the respect to your time domain. But we also have some drawbacks. First drawback is for system with a very large time constant. It will be very hard to find the response. Because the time domain response is giving you the transient behavior also, but in frequency domain we are only considering about the steady state response of the system. Because the time required for the output to reach the steady state for each frequency of the test signal is very high. So this is the first drawback of the system. And the second is the frequency domain response test obviously cannot be performed on non-interruptible systems. A single sort test is more convenient even through the computation of transfer function from the system. So due to this, we will be doing the frequency response analysis. Let's consider a system is RT equal to A sin omega t, and GS we have given. So when we convert it into omega, so it will become GJ omega, and GJ omega will be having a magnitude, that is magnitude of GJ omega and angle of GJ omega. So at system frequency, the output signal is CT equal to A magnitude of GJ omega sin omega t plus angle GJ omega So the amplitude of the output sinusoidal signal is obtained by multiplying the amplitude of the input sinusoidal signal and the magnitude of GJ omega. So amplitude of this signal output will be A into GJ omega. That is magnitude of input signal into magnitude of transfer function signal. And then phase of the system angle will be omega t plus angle of GJ omega. The phase of the output signal is obtained by adding the phase of the input signal and the phase of the GJ omega at omega. So we will be finding out this response. And now because we have considered or analyzed a time domain system of the system, so we require to find out the relation between time domain and frequency domain. So when we are finding out the relation between time domain and frequency domain, we have analyzed a system and we have find out the various quantities for the system. And on the basis of the time domain and relation between, we have defined some quantities as we have defined in time domain. So in frequency domain, it is known as resonant frequency. Resonant peak and bandwidth. So as we have in the time domain, we have rise time, peak overshoot, and correspondingly we have resonant peak, resonant frequency and bandwidth in the frequency domain analysis. And now we have to find out the relation between these two. So when we are talking about a second order system, Ts equal to Cs upon Rs, and that is omega n square upon S square plus 2 delta omega n S plus omega n square. This is a second order system which we have already discussed. So the sinusoidal transfer function, we will be putting S equal to j omega in this. So Tj omega will become omega n square upon j omega square plus 2 delta omega n j omega plus omega n square. So it will become 1 upon 1 minus omega upon omega n का होल स्क्वायर प्लस 2 डेल्टा ओमेगा अपॉन ओमेगा n इंटू जी। तो इसको खोलेंगे, इट विल बिकम माइनस ओमेगा स्क्वायर, ये हो जाएगा j2 डेल्टा ओमेगा n अपॉन इंटू ओमेगा, एंड दिस इज ओमेगा n स्क्वायर। ओमेगा n स्क्वायर को पूरी टर्म से डिवाइड कर दिया तो वी गेट 1 माइनस ओमेगा अपॉन ओमेगा n स्क्वायर प्लस 2 डेल्टा ओमेगा अपॉन ओमेगा n इंटू j. So for analysis purpose, I will be putting omega upon omega n equal to u. For simplicity, I have done this. You can do the calculation with the help of omega upon omega n. But for simplicity purpose, I have done this. So I have written omega upon omega n as u. So tj omega will become 1 upon 1 minus u square minus 2 delta u j. So now we have to find out the magnitude of tj omega. So magnitude of tj omega will become 1 upon under root.
सर वहाँ नीचे में माइनस होगा या प्लस होगा सर? ओमेगा स्क्वायर यू स्क्वायर माइनस, ऊपर में प्लस है ना सर?
ये प्लस,
यस सर।
तो 1 माइनस यू स्क्वायर का होल स्क्वायर प्लस 2 डेल्टा यू का होल स्क्वायर. This will be the magnitude of this function. Simple, this is real value, this is imaginary value. So it is under root 1 minus u square का होल स्क्वायर प्लस 2 डेल्टा u का होल स्क्वायर का अंडर रूट. This will be the magnitude. And angle of tj omega will be minus tan inverse 2 delta u upon 1 minus u square. This minus because it is on lower term, तो lower का angle minus हो जाता है, तो it will become minus tan inverse 2 delta u upon 1 minus u square. So the response of the system will be steady state response. So as we have find out, magnitude is the magnitude of the input signal into magnitude of the gj omega, that is tj omega. So it will become 1 upon under root 1 minus u square का whole square plus 2 delta u का whole square, and it is sin omega t plus phi. Phi is minus tan inverse 2 delta u upon 1 minus u square. This is your response CT for the system. So if u equal to 0, so when we put, this will be your m and this will be your phi. So when u equal to 0, your m will become, this will become 0, this will become 0, so under root 1. So that means m will become 1 and phi is tan inverse 0 by 1. That is 0, so that is 0 degree. When u equal to 1, m will become 1 minus 1 will become 0. So under root this will become 1 upon 2 delta. And your phi will become 1 minus u square is 0, so tan inverse infinity. So that means minus 90 degree. When u tends to infinity, so your m will tends to, because u tends to infinity, so it is 1 by 0, so that means this is also 1 by 0, so infinity, under root infinity, so it will become 0. 1 upon infinity, that will become tends to 0, and phi equal to, it will become minus 180 degree. So if we draw the magnitude and phase angle characteristic, this is U, this is your M. So if you can say this curve will be like this. It will be starting from 1, because at 0, then we have a maximum value, and after that it will be continuously decreasing, because you can say this at U equal to 0, M is equal to 1. At U equal to 1, it is 1 upon 2 delta, and then U equal to M tends to 0. So it will be finally moving towards 0, and it will be first. So if delta is less than 0.5, if delta is 0.5, this will become 1. If delta is less than 0.5, so this term will become less than 0.5, so it will be higher. And if delta is less than, greater than 0.5, so it will become less than 1, and then it will be tending towards 0. So this will be your plot for M with respect to U. And if we draw the angle phi with respect to U, so we can easily say that it will be starting from 0 degree, then reaching to 90 degree, and then it will be reaching to minus 180 degree. And this will be like this. And this is 90 degree at U equal to 1. So the frequency where M has the peak value is known as resonant frequency. So first term is resonant frequency. So resonant frequency is the frequency where M has the peak value. This is this point. The frequency at MR, maximum value of, so that will be known as resonant frequency. And then we have resonant peak. So resonant peak will be the maximum value of the magnitude. Maximum value of M will be known as resonant peak, and then we have bandwidth, range of frequency, over which the magnitude M drops to 70%, 70.7% from its zero frequency value. So bandwidth is the range of frequency where the magnitude M will be dropping from 70.7% from its zero frequency value. So when it will be reaching to your 0.707, that is known as bandwidth. So now we have to find out the relation and calculate the values of resonant peak, resonant frequency, and bandwidth. So first is resonant frequency. So resonant frequency, so because it is the frequency at which the magnitude of the frequency response has peak value, is known as resonant frequency, and it is indicated by omega r. And as you understand, to find out the maximum value, we have to make dm by du equal to 0. So to calculate the dm by du, we have dm m as 1 upon under root 1 minus u square का whole square plus 2 delta u का whole square. This is the magnitude of the system. So now to find out the maximum value, we have to differentiate this term with respect to u. So it will become dm by du will become, it will be minus 1 by 2. नीचे वाली टर्म का क्या हो जाएगा? 1 minus u r square का square plus 2 delta u r square. इसकी पावर थी 1 by 2, तो that will become 3 by 2. प्लस 1 हो जाती है पावर, एंड ऊपर हो जाएगा आपका 2 1 minus u r का होल स्क्वायर minus 2 u r plus 8 delta u r. किसी को याद हो तो इसको यूं का यूं रखते हैं और सेकंड को करते हैं, एंड देन सेकंड को भी रखते हैं और इसको करते हैं. तो जब इसको करेंगे तो इट विल बिकम 4 delta u r and this will become this.
सर आपने u को ur क्यों कर दिया सर?
क्योंकि हम u फ्रीक्वेंसी पे निकालेंगे ना, तो u की वैल्यू जो है वो इस पे ur हो जाएगी ना. फॉर इजीली अंडरस्टैंडिंग है, आप नहीं रखोगे तो भी कोई दिक्कत नहीं. मैंने तो सिर्फ ur, ताकि ये हमें ध्यान रहे कि हम ये जो काम कर रहे हैं इट इज एट रेजोनेंट फ्रीक्वेंसी. u की वैल्यू रेजोनेंट है.
ओके सर.
तो इसको हमें इक्वल टू 0 करना है. तो दिस विल बिकम -1 by 2 1 minus ur स्क्वायर का होल स्क्वायर प्लस 2 delta ur स्क्वायर की पावर -3 by 2. This will become -4u, sorry, plus 4u. ये हो गया 4ur, तो इट इज 4ur. तो अंदर बच गया 1 minus ur स्क्वायर का नेगेटिव प्लस 2 del स्क्वायर. equal to 0. That means 4 UR square minus 1 plus 2 del square equal to 0. So this will become UR square plus 2 del square minus 1 equal to 0, and UR square equal to 1 minus 2 del square. That means UR equal to under root 1 minus 2 del square. That means omega R equal to omega n under root 1 minus 2 del square. So this is the relation between omega n, delta, and omega r, resonant frequency. So because a second order system, we know the value of omega n, we know the value of delta. So when we putting this, we will be finding out the resonant frequency of the system. So now we have to calculate second term, that is resonant peak. So resonant peak is the magnitude of the signal at resonant frequency. So MR will become 1 upon under root 1 minus UR square plus 2 delta UR square, because MR is the resonant frequency. And now we have UR equal to under root 1 minus 2 del square, or we can say 1 minus UR square equal to 2 del square. तो ये वैल्यूज को यहां रख देंगे MR में. So we get MR equal to 1 upon under root 2 del square का whole square plus 2 delta under root 1 minus del square 2 del square का whole square. Simple, कुछ नहीं किया. We have put the values of UR. UR is 1 under root 1 minus 2 del square. तो 1 minus 1 हो जाएगा. तो that will become UR की जगह 2 del square का whole square, और 2 del पहले से था, और UR is 1 minus 2 del square का under root, वो रख दिया. So we get 1 upon 2 del square and 2 del square को बाहर ले लिया, तो this will become 2 delta under root 1, and this will become 1 minus 2 del square. So that will also become 1 minus 1 2, so that will become 1 minus del square. So this is MR. MR is only dependent on the delta of the system, and MR does not depend on the frequency of the system. So resonant peak in frequency response corresponds to the peak overshoot in the time domain response for certain value of damping ratio delta. So the resonant peak and peak overshoot are correlated to each other.
Excuse me, sir.
हाँ
सर कल्पना मैम ने अभी एक टेस्ट शेड्यूल किया है सर.
तो 10:30 से होगा.
हाँ 10:30 से सर, बट मैम ने लिंक अभी सेंड कर दिया है.
हाँ तो अभी 2 मिनट में खत्म हो जाएगी क्लास.
ओके मैम. ओके सर. ओके.
तो दिस इज योर MR, and last is bandwidth. So bandwidth is the value when M will become 1 to 0.707. So that means we have to calculate when m equal to 1 and we have to calculate when m equal to 0.707. So for this, we will be saying that at u equal to 0, m equal to 1, so m will become 1. And for 0.707, we have m equal to 1 by root 2. That is 1 upon under root 1 minus ub square का whole square plus 2 delta ub whole square. तो ये हो जाएगा 2 इक्वल टू 1 माइनस ub स्क्वायर का होल स्क्वायर प्लस 2 डेल्टा स्क्वायर ub स्क्वायर. And when I will solve it, I get the value of ub as, or omega b as omega n under root 1 minus 2 del square plus under root 2 minus 4 del square plus 4 del 4.